is Honors Chapter 3 Test Hints. We're starting with hopefully 1 through 20 here in 6th period class, and then taping the rest of them in next period class so that everybody can go to Moodle and find both parts. Alrighty. Are we ready? Oh, now they don't talk. Alright, test hint number 1. What is it about atoms that makes the law of conservation of mass true? What is conservation of mass?
It can't be destroyed or created.
Can't be created or destroyed. So whatever we put in, we're going to get out. How come? What is it about atoms that allows for that? Even though there's all those like changes and exploding penguins and fireworks, yes?
Atoms of the smallest part of matter not retain chemical properties.
Yes, there's one word that sums all that up.
Oh, well, sorry.
No, that's the perfect idea.
Smallest particle?
No, one word that was not mentioned there.
Magic.
Indivisible.
Under God.
Yes.
One nation.
One nation, one atom, indivisible. Under Avogadro. Okay? The fact that atoms are the smallest bits of stuff that have all those properties allows for that. So in chemical reactions and stuff, the atoms are all still there, they're just rearranged and grouped differently and so on. Okay, hint number 2, how to calculate a simple proportion that shows the law of definite composition. Hints 2 and 3 are very similar. So, if we have a substance made, or a compound made of elements, fake elements A and B, what can you tell me about the proportion by mass between those?
A and B is constant.
The ratio between A and B is constant. So whatever the proportion is, part of that is going to be A, and part of that is going to be substance B, and that's always a set proportion for it to be that compound. And that is a ratio by mass. Now number 3 is very similar to that. There will be using fake elements X and Y or some other letters of the alphabet, and this time giving you some actual numbers. Okay?
What do they mean calculating a proportion?
Let me show you what do they mean calculating the proportion. In fact, I can show you that with water. In water, there are 2 hydrogens to 1 oxygen, but it's actually not a 50-50 split. The oxygen is much more massive than hydrogen, so even though there's 2 hydrogens, by mass, oxygen is going to be, we'll round up, say 16 grams, and hydrogen is 2 grams. What ratio is that? 1 to 8. Okay? So if you were to compare that, or say you're making not 18 grams of water, say you want to make 32 grams of water. What's the ratio between hydrogen and oxygen if we're making twice as much water? 1 to 8. Okay. And this question will have some numeric examples to show that. Number 4, the definition or description of the law of multiple proportions. Okay. How do multiple proportions differ from definite proportions?
Definite is always the same.
It's just like
Definite is always the same, so is multiple within a compound, but what? We did this with FSR. In the fastener and ring lab, we made FSR, and there was a ratio, we calculated that. Then we made FSR2, and there was a set mass ratio between the R and the FS. And then we made FSR3, and there was still a set ratio between the R and the FS. But what did you notice when we compared these 3 compounds? Yeah, it was like a 1 to 2 to 3 mass ratio of rings to total. So the fact that this represents definite and multiple proportions. We've got a distinct mass ratio between the atoms within any given compound, but we can make more than one compound with those atoms. That's what makes it the multiple proportion part. Same atoms could come together in other ratios. Number 5, how Dalton described atoms in his atomic theory. Here is the test question. According to Dalton's atomic theory, atoms, what? What do we know about atoms? Yep.
Made of
It's got Dalton
extremely
right here.
small particles,
Extremely small particles, yes,
chemically alike,
chemically alike,
different elements of chemical. I can't read that. I can't read that either. Simple ratio.
there are simple ratios between them, yep. Can they be broken down?
Chemical reactions.
Chemical reactions make those simple ratios. Can the atoms be broken down?
That's probably what this says over
No,
here.
I don't think so. Anyone? Can the atoms be broken down? No, the atoms can't be broken down, okay.
It probably says that.
No, it doesn't.
Cannot.
All right, cannot, right.
And
And anything
I
else?
can't read that last part.
Okay,
What are you reading?
so, his notes.
It's tight.
Oh, he's never seen a note last year.
Ah,
The
okay.
Dobbs binder.
Very good. Okay, so everything's made of atoms. Atoms of an element are chemically alike. They're different from another element, but those atoms are chemically alike with each other, and so on. Dalton did not realize two things, which is probably going to be another test question here. He did not know that there were things smaller than atoms. So he didn't know that there were protons, neutrons, and electrons. In fact, that does tie into test hint number 6, or 6 and 7. He did not know that there were protons, neutrons, and electrons, so he thought atoms were the smallest you could get. And once we figured out neutrons, his whole business about all atoms of an element are chemically alike got changed up a little bit. Because with neutrons, now we know there are different what? Isotopes. Awesome. Good. So he did not know about isotopes. And those differ because of the number of neutrons, which of course affects the mass. Alrighty? And there are going to be 3 questions in a row about Dalton's theory. Kind of in general, if you know all those parts, you'll be fine. And then 2 of them are which of the following is not, or all of the following except. Okay, so if you know the 5 parts, you're basically being asked that 3 different ways. So that was 5, 6, 7. Number 8, what happened to the rays in the cathode tube during Thomson's experiment? JJ, what did JJ do for us?
Who's JJ?
Who is JJ?
The jet one.
JJ Thompson.
JJ Thomson and his something tube.
Cathode ray.
Cathode ray tube. See, you knew it.
Oh, he shot.